All right, so here we're looking at similarity as it relates to 3D figures. So I'm going to start off today with a little review. So if the scale factor of two similar triangles is 4 to 5, find each of the following ratios. So here, if I look at this visual, right, I'm told that the scale factor is 4 to 5, and I know that that's the ratio of the new to the old. So that is 4 to 5. So when I think about the directionality, right, we are shrinking it, starting here with the pre-image and finishing here with the image. So I'm reading it in this direction like so. Again, pre-image, image, or think of it as old to new. Okay, so any sides that we have are going to have that same exact ratio as the scale factor. We can see that here. This side is 4, this side is 5. So sides will have the ratio of 4 to 5. Anything that deals with segments will have the same ratio of 4 to 5. So altitudes, that's the perpendicular segment that connects vertex to base. So the altitude here would match here. They'd be corresponding in the same ratio, 4 to 5, as that scale factor. So altitude, 4 to 5. Okay, the medians, if I put my midpoint right here and my midpoint right here and drew in a segment that connected the vertex to that midpoint, and then here to here, those would be corresponding medians. They'd have the same relationship as the scale factor, 4 to 5. Okay, mid-segments, so if I put in a midpoint here to here, a midpoint here to here, and then connected those segments, those are mid-segments. And again, they'd have the same ratio as a pair of sides as the scale factor, 4 to 5. Okay, perimeter, well, perimeter is just the sum of all of the sides. So if I knew all of these sides and all of these sides, they would all be in a ratio of 4 to 5. So perimeters would have to carry that ratio as well, 4 to 5. Okay, but not area, never area. Area, we're looking at the number of non-overlapping unit squares that fill up each shape. So for area, we take that scale factor and we square it. So the 4 gets squared, the 5 gets squared, right? 4 squared to 5 squared. We have a ratio of 16 to 25 instead. All right, so a little review from when we were in similarity, and now we're going to extend it to go 3D. So my next diagram right here, I have two cubes that are similar. So if I look at the sides that are marked, and I think of, well, what's my scale factor here? Again, ratio of new to old. Right, here's my old to new. That would be an 8 to 3 ratio. So that's my scale factor. So my base edges for cubes, they're all the same, right? So these sides, they're holding right there, and I'm just doing it in the ratio of new to old, so 8 to 3. Okay, my heights, right, they're really the same as all of my base edges, my sides, also 8 to 3. Anything to do with segments will have the same ratio, 8 to 3. So the diagonals, if I connect opposing vertices here to here, here to here, same ratio, 8 to 3. But not area, never area. So area, again, non-overlapping unit squares. So base area, surface area, right? They're going to be the same ratio. So I take that 8 to 3 and I square it. So 8 squared to 3 squared gets me 64 to 9. Right, that would be my ratio here. And then it's going to be the same thing for surface area, 64 to 9. Okay, now how do we extend that to volume? Right, if I go to volume, well, volume, we're looking at the number of non-overlapping unit cubes that fill up a figure. So now we take that scale factor of 8 to 3 and we raise it to the third power. We cube it. So we need 8 to the third power, 3 to the third power. So 8 times 8 times 8, we're at 512. 3 times 3 times 3, we're at 27. Okay, and then lastly, what is the scale factor? We said that right in the beginning, 8 to 3. All right, let's flip to the back. All right, so here I'm just going to summarize what we've just said. So we know that we start with a scale factor. So think of that as the ratio of A to B. Okay, and that's going to be the same ratio as any sides, any heights, diagonals, perimeter, etc. Basically any segment relationship. Let me write that. So same ratio as any segment relationship. So again, same ratio as any sides, any heights, any diagonals, any perimeters, etc. Okay, for area, we take that scale factor and we square it. So the A gets squared, the B gets squared. And we know that area is area, so that could be one singular base area or the sum of all of the faces together, the total surface area. Okay, and then for volume, we take that scale factor and we raise it to the third power. We cube it. So we're looking at A cubed to B cubed. All right, those are our ratios. So now we can use those to solve for certain problems. Let me slide this up. All right, example 3, we're still looking at a heptagon, so something in 2 dimensions, and we're told what the scale factor is. So we know that A to B is 5 to 3. So if we read it this way, if we apply it 5 to 9, right, we're going to shrink something down. And if I want to enlarge it, I would look at its reciprocal of 9 to 5. So here, if the smaller heptagon, right, we're told the smaller one has this perimeter, 123 centimeters, find the perimeter of the larger heptagon. So here, if I think about what my perimeter ratio would be, it would be the same as my scale factor, but I need to make sure that I'm applying it to either make my shape larger or smaller. So I'm going to take that 123 and multiply it by the perimeter ratio that would make it enlarge, right? I'm going from small to large. So I look at my scale factor and I take it as the reciprocal, 9 over 5. So here, if I multiply that out, 125 times 9/5, I just get 123. 123 times 9/5. Typed it in wrong. There we go. So we get 221.4. So our answer here would be 221.4. And then just our units would be centimeters. Okay, so then here we're looking at if the larger heptagon has an area of 240 centimeters squared, find the area of the smaller heptagon. So here I'm talking about the larger shape with this area, and I want to look at the smaller shape. I want to shrink it down. So I start with the 240, and I want to use the area ratio that's going to shrink it. So if I want to shrink it, then I'm looking at the 5/9, but as a quantity squared. So really I'm looking at 240 times here 25 over 81. All right, so if I have 240 times 25 over 81, make sure I type that in right. Oh, looks great. We'd say, oh, that's about 74.0741, and centimeters are squared. Okay, so moving on to the next one. Here I'm giving you a surface area to start. So surface area ratio for two similar right pentagonal prisms, 49:16. So here that is a squared to b squared. So if I square root that 49 and that 16, that gets me a scale factor of 7:4. Okay, so now here, the larger prism has a volume of 450 units cubed. Find the volume of the smaller prism. So I'm going to start with that 450, and I want to multiply it by a volume ratio that's going to shrink it. So when I look at this ratio, I need to look at the reciprocal, so 4/7 and cubed. So I need 450 times 64/343. All right, and that's going to get me, let's type it in together, 450 times 64/343. So I get 83.965. And units are cubed. Okay, if the smaller prism, so starting small, has a side length of 12, find the side length of the larger prism. So if I start with 12 and I just want a side length, then I'm just going back to the same ratio as my scale factor, just thinking, am I trying to make it bigger or smaller? And since I'm starting small and I'm going big, I'm just multiplying by 7/4. So here, if I multiply across, that is 84/4, which gets me a nice clean 21 units. All right, one last problem. All right, so here I'm starting you off with a volume ratio instead. Still looking at two similar right hexagonal pyramids. Here's the ratio. So here, since it's volume, it must be a cubed to b cubed. So I'm looking at the cube root of 27 to the cube root of 8. So 27 is 3 times 3 times 3. So that means I'm looking at 3. I'm looking for 3 of the same. And then 8 is 2 times 2 times 2. So the cube root of 8 ends up being 2. So I can see that my original scale factor is 3:2. So if the smaller pyramid has a base area of 57 square units, find the base area of the larger pyramid. So I'm going to start with that 57, and I want to enlarge it for area. So I need to take this scale factor, right? That's making it bigger. So I'm taking that 3/2, and I'm going to square it for area. So I'm looking at 57 times 9/4. Okay, and that's going to get me 128.25 square units. Okay, last variation. If the larger pyramid has a slant height of 23 units, find the slant height of the smaller pyramid. So again, I'm starting large and I'm shrinking down to something small, but we're looking at slant height. So I start with that 23. I want to shrink it down, and I'm talking about slant height. So here that should be the same as my scale factor. So just looking at my ratio, that's going to shrink it down. So just the 2/3. All right, so that's going to give me 46/3, and that's really just going to be about 15.3333 or 15 1/3 units. Either way is fine. I'll always take the fraction. So 15 1/3 units, always okay as well. All right, that's it for today. Have a good day.